What's going on, folks? It's Mike here, and today I'm going to be talking about some design patterns. The design patterns, as a reminder, are blueprints or common recipes that can help you solve a problem. They're not perfect, there are trade-offs, and you have to figure out how to apply certain design patterns in the right places. That said, though, I want to talk about a really cool behavioral design pattern called the command pattern. So, just to back up for a second and remind you what a behavioral pattern is, a behavioral pattern allows you to just focus on how your objects are interconnected. So I'm going to be demonstrating this in C++ and using objects to sort of encapsulate some sort of behaviors. That way we don't have to follow complicated control flow. We can just think about things on sort of an object basis. That's one of the goals of a behavioral design pattern. Just looking at the behaviors of our objects and how they communicate and achieve their responsibilities. And the specific behavioral design pattern I'm going to be looking at is called the command pattern. And this goes by other names, so sometimes you might hear as the action or transaction pattern. But basically, it's a way to take objects and model them as commands that execute actions. So the command pattern can be useful in a way to have object-oriented or objects put together and used as callback functions. You can enqueue objects in sort of a command queue, such as the name comes from the pattern. And it's also useful for things like building undo and redo systems. We'll see a way to do this in our example today, and we'll go ahead and get started in a moment. But before we begin, I just want to bring attention to two books that are going to be really useful if you want further resources and all the sort of nitty-gritty implementation details. So, the Design Patterns book, also known as the Gang of Four book, is an excellent book for reading about the command pattern as well as many other popular patterns. And another very useful book is known as the Game Programming Patterns book. So, this book here is written by Robert Nystrom, and it's actually a free book here. So, we can go ahead and read it from the web. So again, with that said, this is a free book, but I do have to give credit where credit is due, and I have purchased this book because I really think it is a great book. It's a testimony to the author for doing a really nice job writing the book and supporting them. I'm not sponsored or anything, but I just wanted to throw a shout out there because this was a very useful book for me to learn some of the design patterns and have two resources to look at. All right, so with that said, let's go ahead and dive into the command pattern. And before we dive in, though, let's just try to understand this pattern a little bit. Okay, so I'm going to go ahead and switch to the drawing board here, just so we can understand the pattern. And if you want, you can go ahead and take a few moments to read in the text the command pattern here. This is essentially what I'm going to draw out here, and I'm going to use a similar example here of modeling different commands as button presses or commands on, say, a game controller. So there's a nice illustration here where Nystrom, the author of the Game Programming Patterns book, is modeling commands when you press the X, Y, B, or A button to do some sort of function. But rather than having a specific function call, we encapsulate things in a class called command and then execute those actions here. Okay, so there it is. Just a little bit bigger here. Okay, so again, let's go ahead and just illustrate what this allows us to do here. So how I'm going to approach this problem is, again, let's say I have some sort of, game controller, and I'll draw it like this, maybe an old school Nintendo controller or whatever. We've got our buttons here and, 4 buttons here. So when I press this particular button here, and let's say it's a PlayStation controller, so I'll put the X there. We want some command here. Now, depending on what the game is, maybe this is a jump action, or maybe it's an accept action if you're looking at a menu, or enter. Right? And we have these various commands depending on the context that we're in. It would be really useful if I could wrap all of these different actions or commands into a common class. So I could say each of these are a type of command here. So if I just sort of draw this as an inheritance hierarchy here, all of these different commands would inherit from one common class. And that way, my X button can just accept one of these commands here. It doesn't matter. So I can just sort of model this, for example, command And let's just make this a pointer. X equals, some other type of command here. Maybe it's jump action or whatever, we've instantiated this as. Okay, so that's the basic idea here. Now, what makes this really powerful here is that since I can encapsulate things into objects, I can perform actions on them. So for example, I can just now have the x dot execute, for example, which would be a member function of this command class here. So let me go ahead and just illustrate that and point that to you in the Nystrom code, that every command has or must have an execute action. Why must it? Well, in C++, when we have virtual void and assign something to 0, we call that a purely virtual function. So it must be implemented. Okay, so that is to say, we must, in our jump command, implement execute this member function here. And likewise, for accept or enter or any other amount of commands that we have, we must implement the execute function. Now, what also makes this very powerful is since we've encapsulated everything, or everything is a type of command, we can actually delay or control when we actually execute. So for example, I could immediately, when I hit X, say, okay, call, whatever the appropriate member function is for, this variable here. So execute, which happens to be some sort of jump command. But I could also delay that and queue these commands. So maybe I have some data structure here, or I have some, command 1, command 2, command 3, command 4, command 5, etc. So that's the idea, and these are all commands. Okay, and maybe we have some sort of data structure. Maybe it's a queue, maybe it's a stack. Maybe, in C++ we like to use vector. So I just have a vector of commands here. Okay, and maybe these are pointers or whatever. Again, we probably want to be a little bit careful storing a pointer here, but that's the idea, that we would have each of these commands here. Okay, so then this would look like C1, call your execute function, and so on. Now, the last thing I'll mention before we do a little bit of live coding is not only can we enforce that we have an execute command, but we could also have C1 and then implement undo or any other associated command. So in a sense, I'm able to walk through this command structure here of vectors and execute all of the commands. But I could also walk through this structure here, which happens to be a vector in this example, and undo all the commands. And the user would implement whatever the opposite of jump is. So maybe, not jump or return to your previous position or whatever. In the context of a Word application, for example, where you're highlighting text and maybe you delete something, you could implement an undo action which returns that text. Right? So you have this history of commands here. So I might call this history here. With our vector. Now, you'll have to think a little bit about how to implement this. It's actually a common homework problem. So, using perhaps stacks, an undo and a redo stack might be a hint as to something useful to do. Okay, so where I want to go ahead from here is just do a little bit of live coding now that we sort of understand the pattern or how to model it. And let's go ahead and see how we can do things in C++. Okay, so I'm just going to shift things over here and open up our window. And again, here's a little reminder of what we're trying to achieve. And I'm just sort of focusing on this hierarchy for now, this command hierarchy. And if you want, when you're programming this, it can be a useful reference to also look at the Nystrom book if you want a good online resource just to see the command pattern here and what we're doing here. So this idea of what's going on with, say, a jump command here. Now, let's go ahead and create a source file here. And I'm going to go ahead and make this bigger here just so you can see all the text here. And I'm going to do this all in one main.cpp file. Of course, you'd probably want to abstract these into different files, but for the purpose of getting everything on the screen at once, I will do this here. So we need some main function here and return, and we want to create our command class here. Okay, so this is going to be our main class here. And what we're going to do is, again, create a, because we're going to be using inheritance, we want to use a virtual destructor here. So this needs to be public. And our virtual destructor. And for now, it's not going to do anything. And then the key is that we have a virtual void execute, and I'm going to model this a little bit simpler here. And this must be implemented by any class derived from command. Okay, and I'm going to go one step further and go ahead and give us a undo function, which would be the responsibility of any class that's derived from command to also implement an undo function, which we'll say is the opposite of whatever execute is. Okay, all right, so what should we do for our commands here? Well, let's just try something simple here. And let me go ahead and sort of illustrate this. Let me give ourselves a little bit of a drawing. And a tip when learning design patterns that I like to follow is just to model the simple case. Sometimes there's multiple ways to do the design patterns, but just to get something working, try to draw it out and understand what's going to happen. So in this window down here, I just want to illustrate, maybe we have some game here that we're trying to model, and we have some character here, and they can sort of move around positions here. So to the left, to the right, up, down, whatever. And we want to store those positions as X and Y positions. Okay, so this seems like something reasonable that you'd want to do in a game. And so for now, let's just model some action of moving. Because eventually what I want to show you is that we can queue up these requests in some vector. These are going to be our sort of move commands that take place, and then be able to move or traverse through this data structure, perhaps undoing the move actions. Okay, so now that we sort of have a concrete idea of what we're trying to achieve, just some command where we can move a character around, let's go ahead and proceed. Okay, so let's go ahead and implement a class here, move, and it's going to inherit from command. So that means, again, that I absolutely must implement these functions here. And I want to go ahead and just demonstrate that by trying to compile the program here at this point. So you should see a bunch of errors at this point if you're following along. So if I do G++, I am using more modern C++ these days, so I like to always compile in C++ 17. And this is the main program, and let's just give it some output. So it'll be the prog program. Okay. Oops, and let me make sure I save here. Okay. One syntax error, missing semicolon. And if I try to compile, actually it's pretty good here. I guess we don't have any complaints here. Now we do have to use this. So if we try to instantiate this without implementing these functions, we are going to have a problem here. So if I try to just create a move command here, like this, let's see what happens. Well, now we get our errors here. The newer compilers are smart enough to say, well, if you never use this, we won't give any errors, but again, it says cannot declare variable m of abstract type move because the following virtual functions are pure. So that's talking about these functions here. Okay, just so that C++ is out of the way. Okay, so we absolutely must implement these functions here. Okay, so we have to do our execute, which is just going to be some void function, and undo. Okay, so let's try to rebuild this, and voila, this time it compiles. Okay, and I still have my move here. So again, when I'm developing these commands, I like to move in very small steps, as small as possible, in order to understand what's going on. So if you're a beginner in these design patterns, that can be very useful. Okay, so now that we have our program compiling, let's actually do something interesting, right? The goal of the move command was to set the X and the Y position to something new, right? We're supposed to move our little character around one way or the other. Okay, so how should we do this? Well, part of our move action, for example, could be to set the position. Okay, so what are we setting the position of? Well, we probably need some sort of character here that we're moving around here. So in the game programming patterns book, they use an actor or some sort of game object. I'm just going to create another class here called the character. Make it uppercase here. And I'm just going to actually make this a struct and keep it really simple here. So they're going to have an X position and a Y position. Okay, and that's what a character is. So now we do have to pass this around, which is fine here. So how do we want to pass this around? Well, as part of our, not our destructor, excuse me, but part of our commands that execute for characters. So we will have to pass this by reference here. So let's go ahead and do that here. So character C. And again, I'm just going to compile this so you can see that the errors that are again going to arise here, that we need to match our signature here. Okay, so that's always important that we do that. And let's have our character here, C. Okay, and our character that we're moving around. Okay, so now if we recompile, just need to add a semicolon there, and we're good to go here. Okay. All right, so now we have our character. They have an X and a Y position, and we can move them around. Okay, and we do want to do something more interesting, like update their position. So maybe we have some function here for moving them, and we'll just call this a void function move and update their X and their Y position here. Okay, so I might write this like this, just for a little example. So X equals the new X, Y equals whatever the new Y position is. Okay, and then we update it as follows. Okay, so now that we've got that compiled, let's go ahead and try to model what we're actually doing here. Okay, so let's just start by creating a character and creating some commands to move them around. Okay, and then we'll think a little bit about what is actually going on in execute, undo, and if we actually have enough here to execute our commands here. Okay, so we do need some character in our game here. I'm just going to give a name. That's me, Mike here. And maybe we want to do some moves here. Okay, we want to move and we want to execute those moves on Mike. Okay. So let's see what's happening here. Oops, well, we don't want to construct this here, but rather we want to do our move and execute and take in a character, Mike, as such. And let's go ahead and run our program here. Now, just to make this a little bit more interactive, I want to add just something else to our character class here, a string, and the, say, name of the character here, just to make it a little bit more interactive here. And that's going to mean I should probably have a constructor, and I should probably have some sort of parameter here, taking a string for the name, and I could do this in sort of the C++ way and make this an initializer list here. Some folks also prefer the style where you just do name equals name, so it's super explicit. Either will work here. So now that we've defined a constructor, we should get an error here for our string type, and that we need to construct our object with the appropriate constructor here. So Mike and the character name, Mike. Okay, so far so good here. Okay, and what we probably want to do here is every time we move, maybe we just print out what happens here. So let's do an output here, and c.name space moved. Okay, and I'll put a little end line here. And I'm just doing this to confirm that some action is in fact occurring on our character here. Okay, so I need to include the IOStream output library so that I can do some input output here. And I'm going to go ahead and just reduce this just a little bit so you can see what's going on the full program here. Okay, so let me recompile that, rerun it, and we can see that our action, in fact, did occur here. We've created our character. We've got a type of command here, and we have executed it. Okay, but again, let's push this a little bit further and see if we could maybe delay the execution here. Maybe let's do a series of commands and store them in some sort of data structure here. Maybe a vector, for instance, a vector of commands. Just to, again, illustrate one of the use cases of the command pattern. Okay, so I'm going to need some sort of data structure for that. For now, I'm going to just do things here in a vector to start illustrating this. And let's go ahead and give ourselves a vector. And this is going to be of commands. And I'm just going to call it our command Q. Okay. So every time that I create a move command here for our character, I want to enqueue that. So move 1. And let's give ourselves a few more moves here. Pop out 4. And then we will just move through our command queue. So for int I equals 0, I less than command queue. Actually, another better way, if I know that I want to iterate through, is to use a vector iterator. But I'm actually just going to iterate through these one at a time here. Command queue size, I++. And this time, instead of explicitly calling m.execute, I'm going to be doing that on each of our command queues at index I. And I'm going to execute these actions on my queue. Okay, so let's go ahead and compile. Looks like it's working here. And I run our program. Okay, what happened here? Well, I haven't pushed anything into the queue, so I have to do that. Okay, so each of these commands, as I create them, I'm going to go ahead and enqueue them. The command queue, push back, and 1. Okay, and repeat this. Now, again, this is a sort of slow way of doing it, but I'm just being very explicit. Usually you're going to handle this by when you press a mouse click, some command gets enqueued, and then you maybe execute that command immediately, or you can defer that action to happen later, which is what I'm choosing to do here for our moves. Okay, so let me go ahead and try to rebuild this. Oops. So we're getting quite a number of errors here, and it says, okay, static insertion failed. That doesn't quite like that I'm just building this move commands on the stack and then just pushing those into our queue. So there are a few fixes here, and this is probably how I actually want to model the command for this particular example. And what I likely want to do here is I actually want to store the pointers here. Now, why I'm doing this here, and let me go ahead and create each of these. And these are each going to be new moves, which are types of commands. So we can store them in our vector again. And just give me one moment here. New move. New move. And, well, we are now need to execute as follows. Okay? So what we're doing here, since we're essentially deferring or controlling the execution of the command here, depending on where this command is we're sort of responsible for managing the lifetime of our commands. So eventually we do want to walk through this command queue and delete the commands. Now, in this lesson, I'm just going to show the raw pointers. You can make your life a little bit easier by using a smart pointer here so that it'll, when it goes out of scope, essentially clean itself up. That's probably a safer thing to do, but I only want to introduce as few of things as possible here. Okay, so let's go ahead and run our program now. And now we can see Mike moved 4 times, so we are able to execute these commands. Okay, so what about the opposite here? What if I wanted to walk backwards through our queue? Again, you could use a reverse iterator for this, but I'm just going to take the size, -1, while I is greater than -1, and essentially walk backwards through our, what I'm calling our command queue, our vector data structure, essentially an array. And let's see what happens when I undo on Mike here. Okay. And let me go ahead and execute this. And well, we don't have anything for undo. So let's go ahead and print out just a little message to see if we are able to undo move. Okay, so go ahead and recompile, rerun, and now we can see that we are undoing 4 times. So we're executing on the same command. It's still in history that we're storing here in our vector. Now, here's the question though. How do we know it's working? How do I know that these are happening in order? And if I am actually going to our problem here, recording the X and the Y positions of this action that I'm doing, how do I actually record those? Where do I store that information? Well, the truth is I need to store that information somewhere in my move command. So perhaps these could be private variable here. And we have our character here. And I could simply just do int X, int Y, and maybe, depending on what you want to do, you might want to have a reference to this actual character here that you have that you're executing the commands on. Now, again, this is where you can get in a little bit of trouble. So you might want to use something like a weak pointer, for example, to say, maybe if I'm pointing to something, I can undo it. Depends on your system here for you advanced users who are watching this. Maybe a weak pointer is not strong enough. Maybe you absolutely want to hold on to the reference. So you do need to think about that a little bit here. For simplification purposes, I'm just going to store the X and the Y position here so you can get the idea here that what we're doing is moving our character around. Okay, so part of our class here in our character is that we can move it around. Okay, so let's go ahead, and when we execute, we want to do c.move some random value for now will be fine here. Okay, so we need the random number generator, and I'm just going to simply use the rand functions here. So I need time or c time and the c standard lib. I believe that's where these functions are. We'll know in a second if I'm right or wrong. And we should set up our random number generator here. This is the seed for it. And let's go ahead and just generate some random X and Y positions. Okay, so let's go ahead and do it. Random X is going to be a random value, say between 1 and 4, something relatively constrained. A random Y value, also the same, and we'll move a random X and a random Y value here. Okay. And what we want to do as well is store these positions, X, our random X, and our random Y position here. Okay. So what I'm doing here is I'm able to, generate some move. The last action that I did is, well, I want to execute this move and move our character some, random number between 0 and 3 here. Okay, in the X and the Y position. And then I'm going to store that in the actual command here, the move command, as my X and Y. So then when I'm undoing the command, I essentially want to do the inverse of this operation here. Okay, now what's the inverse going to be of this operation? Well, moving, but not the random values, but the negative X and the negative Y. And essentially that would put our character back to their previous position. So let's go ahead and make sure this compiles. Looks like everything compiled. And in order for us to sort of debug this, let's update our cout statement so we can see where we have moved. Okay, so we've moved, and I'm just going to update this to make the output a little bit easier on us. The X and the Y, which is the same as our random X or random Y values here that we're generating. And we have a end line here. And I'm going to copy this line here. And I'll print out our undo here. And I'm just going to label this undo. Okay, and let me make this a little bit bigger so you can see it all in one line here. Let's recompile. Oops, one mistake, copy and paste error, so I'm going to have it twice. For our arrows. Okay, and let's go ahead and see that it compiles, and let's go ahead and run. So the first move that Mike does is 0 and 2. Then I don't move at all. Then I move 1, 3. Then I move 3, 1. So the last action that I did here is to, oops, a little bit of a typo here. This is actually a negative value here. So let's go ahead and make sure we print that out. But it looks like it is working here. Okay, so let me just rerun this again. So 3, 2, 0, 2, 2, 1, 1, 0. So that was my last move. So if I'm undoing the last thing that I did, I'm moving in -1, 0. And then I'd move -2, -1, 0, -2, -3, -2 here. Okay? And how I'm achieving that is, well, I have my history of all my commands, just sequentially ordering them one after the other. And then if I walk backwards from this data structure, a vector, then we can undo our commands. Now, caveats here, there's probably a better data structure for walking backwards. And I'll give you a moment to think about that. So if you pause the video and thought about it for a moment, a stack is actually a really good data structure for maintaining your actions. So that way your last action is always on the top, and then you can pop off the stack and undo that action. And you might actually pop off that command on your stack and move it into another stack if you want to support a redo function, which is essentially executing that command again. What command are you executing? Well, it's your move with the X and the Y. Okay, folks, so let me go ahead and just walk through this code one more time and wrap us up because I think this has been a long enough video. So I've included some libraries to work with some data structures here, and I have a character here. That character was, this person here that we're moving on a map in some X and Y position. And then we started implementing the command pattern here. And the important part with the pattern is that we have execute as a pure function and undo as a pure virtual function as well, meaning that we must implement these. And the key is the execute and its inverse operation of undo. And then when we want to model a command, we inherit from it. So move is a type of command. And then we perform our execute action and our undo. And we're careful to store the sort of state that we're modifying here, which is the X and the Y positions for our particular execute command under move, which we can perform on different characters. And we had to think a little bit about what sort of data we're storing. Maybe if we want to store a reference to this character, meaning as a pointer, or actually a reference type, we could do that as well. And then we did a little example. We set up our random number generator, created a character here, and where we were going to store all of our commands. So this was the sort of command pattern. We're able to have our sort of callback or control where our functions are executed by just pushing them into a command queue, which is, again, just a vector data structure, and execute those commands on a particular character. And we could actually execute these commands on different characters if we had different ones. Or maybe we could look at a series of commands that took place, and maybe that has some meaning in our particular application. So I hope this was a really useful video for you to learn about some of the design patterns. Take a look at some of the resources, the free book, or get yourself a copy of the book, or otherwise the Gang of 4 book otherwise is a good resource for folks working specifically in C++. So hopefully this was useful for the command pattern. If it was, please like and subscribe, and we'll do some more design pattern videos in the future. Enjoy.